For over a century, the name Tyrannosaurus rex has been synonymous with the ultimate predator, a biological marvel that defined the end of the age of dinosaurs. We believed we knew its story, a sudden appearance in the fossil record of North America, roughly 68 million years ago, reigning supreme until the fires of the Chicxulub impact brought the curtain down. But science is a process of constant revision, and a recent discovery in the arid badlands of New Mexico has shattered our linear understanding of the king's lineage. This is not just another dinosaur find. It is a fundamental restructuring of the most famous family tree in prehistory. Researchers have identified a new species, Tyrannosaurus mcraeensis, a predator that lived millions of years before its famous cousin. This discovery challenges the long-held belief that the giant Tyrannosaurus were late-arriving migrants from Asia. Instead, it suggests that the roots of the T-Rex's reign were planted much deeper in the soil of North America, specifically in the southern regions of the isolated continent of Laramidia. As we peel back the layers of geological time, we find that the story of the apex predator is far older, more complex, and more terrifying than we ever imagined. The emergence of T. mcraeensis forces us to ask, how long was the king truly in power, and what secrets are still hidden beneath the desert sands?
The journey to this discovery began not in the field, but in the quiet archives of the New Mexico Museum of Natural History and Science. The fossils, a partial skull and lower jaw, were actually unearthed back in 1983 in the Hall Lake Formation near Truth or Consequences. For decades, they were categorized simply as a standard Tyrannosaurus rex. However, a modern team of paleontologists, using advanced 3D scanning and comparative anatomy techniques, began to notice discrepancies that could no longer be ignored. While the specimen was roughly the same size as a full-grown T-Rex, reaching lengths of nearly 40 feet, the shape of the bones told a different story. The post-orbital bone, which sits behind the eye, lacked the prominent boss or ridge seen in T-Rex, and the lower jaw was more slender and curved. These weren't just individual variations or signs of age. They were consistent morphological distinctions that indicated a separate evolutionary path. By meticulously comparing these bones to dozens of other tyrannosaur specimens, the team realized they were looking at a distinct species. This meticulous forensic work highlights the importance of museum collections. Sometimes the most groundbreaking discoveries aren't found in the ground, but are hidden in plain sight, waiting for the right technology and the right questions to unlock their identity. To the untrained eye, Tyrannosaurus mcraeensis and Tyrannosaurus rex would look virtually identical. Both were multi-ton behemoths with bone-crushing bites and massive hind limbs. But in the world of paleontology, the devil is in the details. T. mcraeensis lived between 71 and 73 million years ago, placing it in the Campanian stage of the Cretaceous, significantly earlier than the Maastrichtian stage occupied by T. rex. The morphological differences are subtle but highly significant. T. mcraeensis possessed a more slender lower jaw, suggesting a slightly different bite mechanic or perhaps a different primary prey source than its later descendant. Furthermore, the ridges above the eyes, which in T. rex are heavy and pronounced to support massive jaw muscles and protect the skull during combat, are noticeably less developed in mcraeensis. This suggests an animal that was perfectly adapted for its specific window of time, an apex predator that was already pushing the boundaries of gigantism millions of years before T. rex reached its final, most robust form. These anatomical nuances provide a roadmap of evolution, showing us the incremental steps required to build the most efficient killing machine nature has ever produced. It's a transition from a formidable hunter to a specialized, armored titan, and mcraeensis is the missing link in that transformation. The discovery of Tyrannosaurus mcraeensis does more than add a name to a list. It completely redraws the map of dinosaur evolution. For years, the prevailing northern origin hypothesis suggested that giant tyrannosaurs evolved in Asia and migrated across the Bering Land Bridge into what is now Canada and the northern United States. However, mcraeensis suggests the opposite. Because the oldest giant tyrannosaur has now been found in New Mexico, it implies that the lineage actually achieved its massive size in the southern regions of Laramidia, the island continent that stretched from Alaska to Mexico.
This southern cradle of evolution was a hotbed of giantism. It appears that while northern tyrannosaurs remained relatively modest in size, their southern counterparts were under intense evolutionary pressure to grow. This leads to a fascinating theory that the giant tyrannosaurs we know and love are actually a Southern American export that eventually migrated north to become the T-Rex we find in Montana and Wyoming. This geographic shift challenges our understanding of how species dispersed across the ancient landscape and suggests that the environmental conditions of the American Southwest were the primary forge in which the tyrant king was truly cast. It turns the traditional narrative of dinosaur migration on its head, placing the heart of the Tyrannosaur empire thousands of miles further south than previously believed.
What drove this evolution toward extreme size? To find the answer, we must look at the neighbors of Tyrannosaurus mcraeensis. The Hall Lake Formation was a vastly different environment 72 million years ago, a subtropical paradise of floodplains and dense forests. This ecosystem was home to some of the largest herbivores ever walk the planet, including the massive long-necked titanosaur, Alamosaurus, and giant horned dinosaurs like Sierraceratops. In an evolutionary arms race, as the prey gets bigger, the predator must follow suit or starve. The presence of these gargantuan herbivores in the south likely provided the caloric surplus necessary to support a predator the size of a school bus. T. mcraeensis wasn't just big for the sake of being big, it was a biological response to an ecosystem dominated by giants. This arms race created a feedback loop. Larger predators forced prey to develop better defenses and larger bodies, which in turn favored even larger and more powerful tyrannosaurs. By the time T. mcraeensis was established, the blueprint for the T-Rex was already complete. The bone-crushing bite, the forward-facing eyes for depth perception, and the massive frame were all adaptations forged in the heat of the southern Cretaceous. We are looking at a snapshot of an apex predator in its prime, millions of years before the asteroid would eventually end its reign, proving that the T-Rex lineage was a long-term success story of the American Southwest.
The identification of a new species within the Tyrannosauridae family is never without controversy. The scientific community is notoriously rigorous when it comes to the King of Dinosaurs. Critics often point out that individual variation, sexual dimorphism, or even pathological bone growth can make a single species look like two. However, the team behind the T. mcraeensis study anticipated these hurdles. They utilized a massive dataset, comparing the New Mexico specimen to every known T-Rex fossil of similar age and size. They found that the morphological gaps between mcraeensis and Rex were wider than the gaps between other recognized species of dinosaurs. Furthermore, the stratigraphic evidence, the layer of rock the fossil was found in, is perhaps the most compelling argument. If T-Rex only lived during the final 2 million years of the Cretaceous, how do we explain a nearly identical creature living 6 million years earlier? The most logical conclusion is that we are witnessing the precursor, the ancestor that provided the genetic foundation for the most famous dinosaur in history. This discovery reminds us that the fossil record is a fragmented puzzle, and our understanding of it is only as good as the latest piece we find. T. mcraeensis is that crucial piece, filling a gap in the timeline that has puzzled scientists for decades and providing a definitive link between the smaller tyrannosaurs of the mid-Cretaceous and the giants of the end Cretaceous.
The legacy of Tyrannosaurus mcraeensis extends far beyond the technical details of its jawbone. It represents a paradigm shift in how we view the golden age of dinosaurs. For so long, we viewed T-Rex as a freak of nature, an evolutionary outlier that appeared out of nowhere to dominate the final moments of the Mesozoic. But with the discovery of mcraeensis, we see that the T-Rex was not an accident. It was the pinnacle of a long, successful, and slowly refined lineage that dominated North America for millions of years. This new species tells us that the tyrant king was part of a dynasty. It speaks to the resilience and adaptability of the tyrannosaurid body plan, which was able to thrive in diverse environments across Laramidia. From the swamps of New Mexico to the forests of Alberta, these predators were the masters of their domain. As we continue to explore the southern reaches of the United States and Mexico, it is highly likely that more cousins will emerge, further complicating and enriching the story of the apex predator. Every new fossil is a window into a world that was more vibrant and competitive than any movie could ever depict. T. mcraeensis is our latest and most profound look through that window, revealing that the history of the world's most famous dinosaur is still being written, one bone at a time. As we conclude this journey into the deep past, the discovery of Tyrannosaurus mcraeensis stands as a testament to the enduring mystery of our planet's history. It reminds us that even the most well-studied creatures can still surprise us. This prehistoric titan, which prowled the ancient Southwest 7 million years before the first T-Rex ever took a breath, has forced us to relocate the origin of the world's most fearsome predator. It has shown us that the path to the top of the food chain was paved with millions of years of adaptation and struggle in a world of giants. The king has a new ancestor, and the throne of the Cretaceous is more crowded than we ever suspected. As technology advances and more fossils come to light, we will continue to refine this epic narrative. But for now, we recognize T. mcraeensis as the silent predecessor, the southern architect of a predatory legacy that would eventually conquer a continent and capture the imagination of every generation that followed. The apex predator's history has been rewritten, and in doing so, the legend of the Tyrannosaurus has only grown more formidable. The king is dead, long live the king, and the cousins who came before.